but out of the box, large language models have some major flaws. At their core, they are just next word predictors. If the AI doesn't know, it might confidently invent a fake rule. And worst of all, they hallucinate confidently. I'm Aditya, founder of CreateBytes, Alteryx Labs, CBX, and Yogi AI. I've been building real world products in AI for a few years now and seeing like a very first hand how this technology goes from a simple research paper to a product that impacts millions. In a production environment, you simply cannot rely purely on this is the absolute blueprint of modern enterprise. Hello everyone, a very warm welcome to all the amazing students, learners, and future AI engineers joining us today. I'm Aditya, founder of CreateBytes, Alteryx Labs, CBX, and Yogi AI. I've been building real world products in AI for a few years now and seeing like a very first hand how this technology goes from a simple research paper to a product that impacts millions. Before we dive into the technicalities, I'm going to give a quick shout out. Our team is actually exhibiting at the Impact AI Summit right here in Delhi today. If any of you are in the NCR region, I highly encourage and recommend that you drop by the exhibition. It is incredibly fun and eye-opening to explore how different companies are using AI, building new things, and evolving in this space. So yeah, we are going to come back again, discuss it at the end. But today's topic, this is retrieval augmented generation. And how many of you have heard about this? You can just raise your hand and let me know about it. Like we'll be sharing a lot of notes about it, but I'm going to give a quick brief about, we all love using GPT, Claude, correct? But out of the box, large language models have some major flaws. At their core, they are just next word predictors relying on their internal memory. Because of this, they cannot access your private enterprise data. Because of this, what happens is they are not able to access your private enterprise data, and they have strict knowledge cutoffs. And worst of all, they hallucinate confidently. Imagine building an AI for an Indian bank and a user asks about the newest RBI repo rate guidelines launched yesterday. If the AI doesn't know, it might confidently invent a fake rule. In a production environment, you simply cannot rely purely on the model's training memory. And this is very important to understand. And that brings up why RAG changes everything around it. Like, what exactly is the impact of RAG? This is where RAG gives us the AI and external memory. And we need to understand this concept. Think of standard LLMs as taking a closed book exam. RAG turn it into an open book exam. Instead of forcing the model to guess from its training data, RAG actively searches a database, finds the exact relevant document, hands it to the AI and says, read this and answer the user. But the biggest benefit here is attribution. And you need to understand this concept because the AI is reading from a document we provided. It can cite its sources. Without citation, AI is just a toy. With it, it becomes legally safe and ready for enterprise adoption. And it is important to know why and how. So we need to understand an important aspect in which we'll discuss in these two slides, which is this RAG versus fine tuning. What happens, and this is something which is very common. A question I get asked a lot by freshers is, Aditya, why don't we just fine tune the model on our own company data? And why to use that? Like, we just fine tune the model. And here is a practical example. Suppose your company changes its Diwali leave policy. If you fine tune the model, you would have to spend thousands of rupees and hours retraining the model just to update that one rule, which is, let's say, the leave policy which has come out. RAG, on the other hand, injects knowledge dynamically. You just delete the old PDF from your database and upload the new one, and the AI instantly knows the new rules. No retraining needed, and it is highly modular. For 95% of the companies out there, they need RAG and not fine tuning, and this is very important, and that shows the importance of this system. And that's the difference when we talk about RAG and fine tuning. Now, there is another important aspect which we need to understand, which is not talked about so often from a, let's say, development perspective, but I'll give you a very interesting brief which gives you a very huge, humongous impact which it creates. So if you follow AI news, you might say, but Gemini 1.5 Pro has a 2 million token context window. I can just upload the entire Indian penal code directly into the prompt. Yes, you can. But should you? That's an important thing. Passing massive amounts of text every single time a user asks a question increase your API cost, which basically is a humongous thing because you're using the token size. But that is not all. And it also slows down the response time. And there is basically a very famous concept which we know about, which is like whenever we are talking in terms of searching in a very huge thing, we say needle in a haystack problem. And if you feed an AI too much information, it actually scans too much and loses precision and forgetting facts hidden in the middle. So to give you an example, an experiment where once you put a big amount of text to it, most of the time it is very precise with the beginning at the end, and the middle important information gets missed. So it's important to understand that even if, let's say, Gemini had a large context video, you cannot just directly send the whole text to Gemini and ask questions to it. It is not going to be as efficient as what you can do with a proper retrieval system. And this brings up a very interesting and important aspect to our overall pipeline. What is the full architecture, the components present in it? So how do we actually build this for production? And it's an important thing because like we can understand the theory, but when we are building it for production, what are the things which need to be taken care of? So for example, what you see on your screen is the full RAG architecture components. This is the absolute blueprint of modern enterprise AI. So for example, it's like a sequential 8-step process. You have data ingestion, then you go towards the text chunking scenario, then you go towards embeddings, then you go towards vector indexing, then you go towards retrieval, and then finally you come towards prompting. Now let's try to break it down and get inside a little bit more detail. So every single layer acts as a strict filter. If you mess up step number 1, step 8 will fail, and it is important to understand. For instance, in India, enterprise data is incredibly messy. Think of complex GST invoices mixed in Hindi, English, and other vernacular PDFs, or dense RBI circulars. Standard PDF loaders just extract garbage text like a dump, and if you feed garbage to the AI, it will definitely hallucinate. And this is where top engineers use state-of-the-art open source libraries like Lang Extract, and it just came in February, and you guys should also try to research about it. Lang Extract uses AI to perfectly structure, clean, and extract entities from messy documents before they even enter your pipeline. And this is a very interesting thing when we talk about RAG and other things, because Google launched something which is very, like, I'll say that right now you can consider this as a SOTA. SOTA means state-of-the-art system. And here's where the industry is moving. This linear 8-step diagram is evolving into agentic RAG, and again an evolution in our RAG architecture. So in an agentic workflow, if the evaluation step at the end detects the generated answer is weak or missing context, an AI agent doesn't just give up and say, I don't know. It autonomously loops back to the step number 5, rewrites its own search query, and searches the database again. Mastering these 8 foundational steps is your absolute gateway to building these advanced autonomous systems, and it is important for us to understand how it happens. And then we'll jump towards an important concept which basically touches when I'm talking about LangChain or let's say agentic systems. To manage this massive pipeline without writing thousands of lines of code from scratch, the industry relies on orchestration framework like LangChain, and there are others too, like Microsoft AutoGen is also an interesting one. Google also has one, but yeah, today we'll just touch LangChain. And the absolute heart for your RAG system is the index, and that's why LangChain indexes. So do not think of the index as traditional SQL database. An index is your AI's semantic brain. It contains the raw text, the mathematical embedding vector, the approximate nearest neighbor method which we know about or we have heard about. It searches the structure to make searching millions of documents amazingly fast, and very, very critical metadata extraction become possible with that. Now, what is this metadata? Metadata is a digital tag, and it is your, you can consider this as something which you can use in a lot of different arenas when you're like utilizing indexes and all. So to give you a practical Indian legal example, suppose you're building an AI lawyer to navigate the new Bhartiya Navya Sachita. You must have heard about BNS program which has come out. If a user searches for fraud, the AI might find 50 different paragraphs about fraud from the last 50 years. How does it know which one applies today? That is something which metadata tells you. So before doing any complex math, only look at chunks where the metadata tag says year 2024 and and section 318. And that's how it figures out. And that's why metadata becomes very important in that direction. For all of you, standard RAG, and this is something which you can always think when you're building these RAG systems, that any kind of standard flat indexing, it evolves in a very rapid direction, and we have seen it doing at a very, very fast pace. And there's a brilliant, like, state of the art, and which we have been using in Create Bytes. We call it Embed Anything, that allows you to build multi-modal indexes. I think the team will share it in the WhatsApp group, exact link of Embed Anything. What it does, you can embed a PDF text, an image of, let's say, any stock chart or any other graph, or an audio file into the exact same mathematical space. Like, it actually, the backbone is on Rust, so it's humongously fast. And a lot of places we have seen it writing near real-time scenario. So we have seen that there's a big adoption of this. Plus another thing which is like a graph RAG. So it's a state-of-the-art concept, and it was basically talked about by Microsoft in their, let's say, open papers too. And what it does, it maps the relationship between entities, allowing the AI to answer very complex scenarios quite accurately and in a very multi-hop direction. And that's something which one should check. So, but definitely look towards the library of Embed Anything. Very powerful. Now, once you have built this beautiful, let's say, highly organized index, you need a way to fetch the data. And that's where the retriever comes in. So retriever is the search engine or the detective for your AI. And it's important how it works. So when a user asks a question, the retriever dives inside the database, but it has to mathematically balance recall, finding all the absolutely correct information, and also ensure some sense of diversity, ensuring it doesn't just return 5 identical paragraphs that say the exact same thing. And there are state-of-the-art enterprise concepts which are present. So there's a concept which is called as hybrid search. So if you're building an AI for an, let's say, Indian e-commerce platform like Myntra or Flipkart, and a user types red cotton kurta under 2000 INR. So we have a standard vector search which looks for meaning. That means it basically doesn't search for something like blue silk sari instead of, let's say, a kurta, because the fashion context is mathematically similar. So there is a chance that the vector similarity may come in the picture. But what we have to do is mix it in a hybrid scenario where it misses the exact keyword red. To fix this, the retriever does a dense vector search with old-fashioned keywords, like, for example, you would have heard about BM25, and then it uses a cross encoder re-ranker at the end. That's something which basically is current state of the art in terms of hybrid search. Something which you should look at. Once you have retrieved it, you use a cross encoder re-ranker on top of it. And that gives you the final result in a very right direction. And in agentic systems, we take this as, like, you can consider, even if, let's say, you go wrong, you can come back and correct it. And there's a model for it which you call HyDE, hypothetical document embeddings, or multi-query retrieval. So Indian users often type broken English queries like PF withdrawal rules tax free fast. So standard retrieval fails a lot of times if you type like this. But an agentic retriever intercepts that bad question, uses a large language model to autonomously rewrite it into 5 perfectly structured English queries, searches the database in a different mechanism 5 different times, and mathematically merges the best result. And that's something which you should look at. And again, giving you an example, hypothetical document embedding, HyDE, which you should look at. We should always, like, think about a golden rule of AI engineering. Retrieval quality perfectly equals answer quality. And this is something which one should know, and I'll try to explain it. That retriever is the single most powerful tool for your AI agent to work in terms of your goals which you define for agents. So when you are into the agentic systems need very good retrieval scenario to work one thing on top of the other, and then again moving forward. So this is important to understand and move forward. Now we are going to jump towards a very interesting thing, and this is a code base. So what you see here, it's basic Python, and you have actually built an end-to-end RAG with just these lines of code. If you look at the code, in less than 20 lines, we load a PDF policy, split it into 1000 characters in chunks, convert those chunks into OpenAI embeddings, and store them in a vector database called Chroma. And then we connect it to a large language model like GPT-4o Mini or whatever you want to use, using a QA chain. And when you ask, explain the leave policy, it can search the PDF and give you a perfect answer. This is your starting line, a starting point, and that is it. And this is how you can just build a basic RAG. And you can just type a prompt and even LLMs can help you build it. So we have to move further from here, and that's why state of the art and other things come in, and the concepts need to be known when we are doing this activity. And see, ultimately you have a QA, retrieval QA, and then from there you got the idea. Now we'll jump towards a section which is called as data ingestion layer. So let's break down the layers starting with ingestion. That was the first thing. So in the real world, data doesn't come in clean text files. It is messy. It lives in PDFs with weird tables, on dynamic web pages, inside company Google Drives, or on YouTube transcripts and other places. So for those looking to build advanced portfolio projects, and I strongly suggest that you guys should do that, look into again Lang extract, because that's where this can be considered as the optimum way of doing it. And what you should do is just install it, try to use it with your current code. What it does, it allows you to extract highly structured data and entities from a lot of messy documents. And so far it was a pain doing it, and there were libraries which were quite good, but this is just amazing and it is very fast. So one should look at that. Now I'm going to talk about two things. One is text loader and the other one is called as PyPDF loader. So these are just coding examples. So LangChain makes ingestion easy. Text loader is fast and efficient for simple text. For PDFs, which are heavily used in legal and corporate sectors, we use PyPDF loader. So the great thing about PyPDF loader is that it treats every single page as a separate document and automatically attaches the page number as a metadata. So as the AI knows exactly which page the answer came from. And now I'll talk about very interesting thing which is called a Selenium URL loader, and then we'll also touch upon Google Drive loader. Very simple things. So what if the data is on a modern website built with React, like let's say IRCTC, or a dynamic e-commerce site? Standard scrapers fail because they don't render JavaScript. For this, we use Selenium URL loader. It actually opens a hidden browser, renders the page, and extract the text from there. So a lot of times when you want to get some data from the website, you can use Selenium URL loader in that context. And for corporate setups such as let's say startup or some bigger company, data is internal. So you'll use the Google Drive loader to ingest massive amounts of internal enterprise documents securely. And again, it is interesting. Now we also touched another component in the RAG architecture, which is text splitter. So once you have the text, let's say you use Lang extract, PyPDF loader, Google Drive loader, or any of these current systems to ingest the data, then what happens? You have to split it into chunks. Why? Because you can't feed a 500-page book to an embedding model all at once, and it is important to understand. Chunking ensures better retrieval granularity. If a user asks about maternity leave in your leave policy, you only want to retrieve the exact 2 paragraphs where it was mentioned, not the entire 100-page HR manual. So bad chunking, this is something which I just talked about previously, that any of these is giving you wrong result, your end outcome becomes like quite bad. So it's important that chunking is done accurately in the right direction, and a bad chunking literally breaks your entire RAG pipeline. And it's important how does it happen and what are the things which one should consider. And I'm going to talk about very powerful concept which is character and recursive text splitters. And again, these are part of chunking. So there are different ways to split text. Character text splitter just cuts the text after a fixed size and it is fast, but it might cut a sentence completely in half, breaking the semantic meaning of it. And to fix that, we use what we call as recursive character text splitter. This is one of the best default choices in the industry when you're talking about concepts of how we should be chunking. It tries to split the paragraph first and then sentences and then words, keeping the logical structure intact. We also add a chunk overlap so the context isn't lost between the two pieces. And again, I've experimented with it. If you do not have a chunk overlap, you can see the difference in it by yourself. There's a big difference when you do a chunk overlap versus what is a chunk overlap. You have one paragraph, you have second paragraph. So you take 2 lines from your first chunk and put it in your second chunk, and 2 lines from your third chunk and put it in your second chunk, so that there is some overlapping and it basically doesn't lose the context when it moves on. So it's interesting and important to know how it works. Now I'm going to talk about another kind of splitters which are like token and then NLTK spacey splitters. So if you're dealing with strict token limits, and which happens with a lot of LLMs, to save the API cost, we use token splitters. But if you are working with complex Indian legal documents or heavy academic papers or research docs, we should use NLP based splitters like NLTK or spacey. They understand actual language syntax and ensure sentences are never broken artificially. So again, very interesting and powerful splitters which are present there. And now I'm going to talk about embeddings and then embedding options which are present for us. And this is something which basically is a very common thing, and most of the things which are happening in the AI domain revolves a lot around the concept of embedding. So embeddings convert human text into arrays of numbers, vectors. And we need to understand how it works. So sentences with similar meaning will, I've talked about it in the previous webinars to understand it. So sentences with similar meaning will have numbers that are close to each other mathematically. So we measure this distance using cosine similarity. So you can use OpenAI, but there's incredible state-of-the-art research happening in open source. And so you do not need to depend upon OpenAI for that. There are a lot of it available online. And one of this, which like is amazing and it's almost near real time, is Embed Anything, which I talked about earlier. So it allows you to build humongously fast embedding pipelines locally on your desktop, laptop, or your machines. And it can embed not just text, but in a multi-modal fashion, audio and images in a very seamless manner. And it's important that we basically look into it. It's very, very powerful. Embed Anything. And I think we'll share the link in the WhatsApp group for us. Now, let's touch a very interesting thing, which is called as Deep Lake Vector Store. And then we'll touch MMR retrieval. Now, once converted to numbers or vectors, we store them in highly optimized vector database like Deep Lake. There are other ones like Python and all to present, which we can use. And when retrieving a standard search, and this is related to the MMR retrieval, which is the maximal marginal relevance. And important that you remember maximal marginal relevance. So when retrieving a standard search, you may get, let's say, 5 documents that all say the exact same thing. MMR is a smart algorithm that says, give me the most relevant answer, but also make sure that the next chunks bring the new diverse information and not the exact same thing. So it improves the answer completeness and prevents the redundant chunks which can come out in this direction. So MMR retrieval, a lot of you may not have heard about it, but it's an important part of the pipeline when we talk about these things. And then we'll talk about another interesting thing, which is called as contextual compression. So even after, let's say, we have done retrieval, chunks contain noise, like a website footer will be present in the chunk. So contextual compression is a state-of-the-art technique where the system extracts only the specific sentences that are relevant to the query before sending it to the large language model. And I'm not talking about sending it to the user, because we have to send it for re-ranking other purposes. So we are talking about when it is trying to extract the data, it does a contextual compression to ensure that we are only sending that specific data, which are those sentences that are relevant to that query. And it reduces the token waste and massively improves the precision. So contextual compression is quite important. Now, let's take one example. Okay, let's visualize a real use case where imagine you are building a support bot for Swiggy or Zomato. A user asks a query. What you are doing is you embed the query of the user, then you search your vector database. Like, you can take it as an option, but I suggest that you should do that. Re-rank the result to get the absolute best matches. Put it in a prompt, and the large language model generate the answer with the sources which you have given to it. And you can notice the logging steps which were there to understand how it all works. And it is essential for any evaluation if you want to do with RAG system, that you have some kind of logging present. If you are not going to log, you will never know why it failed if it failed. So in a very productionized environment, while you are basically following the process where first you embed your query, then you query your vector database, search for it, you basically re-rank your results, and then send it to LLM to give an answer. If you are able to log this whole entire process, you can actually know that even if it failed, why it failed and what you need to do to correct it. And why it is important? Because building a RAG has multiple architectural components, and you need to know and pinpoint exactly where it can fail. And to know that, logging becomes important in that direction. And I'm going to touch very important thing, and this is 2026 February, and this is at the top of the game across the AI industry. So up until now, we have talked about the individual pieces of the entire puzzle: extracting the text, chunking it, embedding it into numbers, and retrieving it. But if you are building a real world software product, how do you glue all these things which are isolated Python functions together? You can understand I'm touching something which is going towards an agentic system. So this is where LangChain or chains come into the picture. And the word LangChain and the word chains. It's important. So think of chains as the assembly line in a car manufacturing plant, like let's say Tata or Mahindra. You don't just throw an engine and wheels into a room and magically expect a car to be driven from out. So it's like the second you put everything together, we have talked about and read about Industry 4.0. They're all pipelines which works in a fashion. And similarly in software too, we are talking about chains. So you need an orchestrated mechanism and a step-by-step pipeline to ensure that this goes in the right direction. Do not get confused when I use the word pipeline or workflow. I've explicitly given a difference between what a workflow is versus what an agentic system is. So I'll not touch that topic. But from the context of it, what we are trying to do here and achieve here is to understand that we need an orchestrated step-by-step pipeline to ensure that this happens in the right direction. So chains act as the glue for the entire application. They orchestrate the entire flow of data. A chain takes the user's raw questions, passes it to the retriever to get the documents, inject those documents into a prompt template, send it to the large language model, and finally parses the output into a clean format like JSON that your front-end web application or mobile application can easily display. Again, I'll touch this thing. Orchestrate the entire flow of data. Who? Chain. It takes the raw question, that what was the question which was asked. It then passes it to the retriever, which is basically our RAG system, to get all the documents which are present. Then it injects those documents into a prompt template where you say that out of these documents produce an answer. So you have predefined prompt where you just add the document text which has been extracted, and then you send this to large language model, which finally parses the entire output and produce a clean format, let's say JSON information or whatever format you want to use to your front-end application. Now, chains allow us to build highly modular, practicable AI architecture. So I am not saying LangChain, I'm just saying chains. Reason being that let's understand the core concept before we jump into the technicalities of this. Understanding this orchestration is very, very, very important and is the stepping stone towards building advanced agentic systems, which are basically quite powerful and are very relevant right now. And this is basically a chain example of what we just talked about. And think of it as like you have the LLM chain, and then you have the raw text, then you put it, and then you have a prompt, and then you're using it. So it's important that you understand the core concept in that direction. Now, I'm going to touch an important aspect, which is basically the part where maybe we'll take some, let's say, a little bit of detail about what's happening from the code perspective in that direction. So we are using something called as a prompt template. So instead of hard coding exactly what the AI should be asked every single time, we create a template with a dynamic variable like topic. Why does this matter? Because in a production environment, let's say you're building an educational app for Indian school students, you aren't asking the questions. The users are asking those questions. A student may say photosynthesis or how does the UPI architecture work? Anything. So the chain dynamically takes their input, injects it exactly where the topic placeholder is, sends the complete prompt to the AI, and returns the simplified answer. And it turns a static AI model into a dynamic interactive engine in just 4 lines of Python code. And this exact structure powers the backend of massive enterprises, which basically talk about AI being used for their bot systems and other things. And this is important. And now this is a huge engineering challenge which we face in production. And this topic is important. That's why I thought of like adding this to in the system. And this is out of like, let's take an example. So large language models are completely stateless. They have the memory of, let's say, something which has very small information related index and all, but nothing else. Like they're stateless in terms of understanding anything. Okay. But they are predictive in nature. So every single API call is completely independent. Do not assume that if I call an API, there's a stateful scenario with them. So if you tell a large language model, your name is Rahul, and in the very next prompt, you ask, what is your name? It will have absolutely no idea unless you have a context memory and other things set up. But like when you are calling an API, think of it like an API call basically gives you an information. And then the next time you do an API call, do not think of it like it has the context. It basically gives you some random name or something, which is like a question like, I don't know, or maybe it remembers from its old context, anything like that. But important part, when you call an API and then you call another API, always remember LLMs are stateless. And that's why this topic topic becomes important. And if you want, you can just experiment with a lang chain, create two agents, use a conversational bot, and if you do not have the conversational memory, they'll not respond back. So imagine building an AI customer support for Zomato or Make My Trip. If a user says, my order is delayed, the bot apologizes. Then the user says, actually, just cancel it. If the bot doesn't have memory, it will respond, cancel what. But if it has, which we talk and call conversation buffer memory. And how do we do that? Basically, we inject conversational memory, like let's say the buffer memory, into the LLM, and it acts as a running transcript, and it silently stores the dialogue history and passes it along with every new question. You understood? So this is an important thing. So you're actually passing it along, and this is being passed as a transcript when you're calling these APIs. But like, I'll give you a pro tip here, because something which you can do. So you must combine memory with your RAG retrieval. If the AI only remembers the chat but doesn't check the company database, clever user can trick the AI into agreeing to a fake 100% refund policy. So memory gives the AI conversational context. Strictly provide the hard, undeniable facts which one should be using with a conversational bot. So again, this topic of conversational memory, and anyone who is using it, they will always experience. I'll tell you my experience that we were in a situation where we were working on product which was basically driven with LangChain, and there was an issue with conversational history because it was not present. So anytime I ask a question, I was assuming that it will give me the answer, but next time it didn't. And our team member came to us and like, this is what is happening, and then we had a discussion, and this is something which you will also face if you just try it out. So I recommend just try this thing at your end, call an API, see how it works, and then pass along the transcript, but use it with agentic systems. Like build a multi-agent, small 2 to 3 agent. You've seen the code, how it works, and then you just call and see how basically the response comes in, and when you pass a transcript, what happens in that direction. Now, I'm going to touch this slide, which basically brings us to the foundation of what top technical companies are actively hiring for right now. A sequential chain allows for multi-step reasoning. Imagine you are processing a massive 50-page commercial lease agreement for an office space in Bengaluru. Step number 1, the first AI chain reads the complex document and summarizes it. A second AI chain takes that summary and specifically extracts exactly 3 hidden penalty clauses in that. A final AI chain takes those extracted clauses and drafts, let's say, a polite warning email to your legal team. So you have 3 different AI chains working in terms of doing things in a sequential manner. So this multi-step reasoning is very powerful. The output of one chain becomes the input for the next one. But we need to understand this because the entire global AI industry is shifting. Sequential chains are very deterministic. They are very hard-coded. So as an engineer, dictating the exact steps are not good. What if the AI can decide on their own? And that is the place where there is a leap, which is change to agentic systems to AI agents. So in AI agentic workflow, you don't hard code the sequence. Instead, you give the large language model a goal and a toolbox. The toolbox might contain a web search tool, a Python calculator, or your LangChain RAG retrieval. And important to understand, this is something which is old, but you need to know why it got replaced. So if you ask an AI agent, compare our company's Q3 revenue with current Indian market trends, the AI actually thinks for itself before acting. There's a highly influential state-of-the-art research paper which I would want you guys to look at, which is called as REACT, R-E-A-C-T. It's basically around synergizing reasoning and acting in language models. The name of the paper, REACT, one should look at. It proves that if you let an AI create a thought loop, it can solve complex enterprise problems autonomously. And this link we'll also share in the group for you, so you understand how it works. I'll also touch another thing. So let's say that agent thinks, first I need to use the RAG tool to find our internal Q3 revenue. Next, I need to use the web search tool to find market trends. Then I will use calculator tool to find the percentage difference, and finally write the report. The AI decides the sequence in a very dynamic manner. So we are moving away from simple chatbots to autonomously digital workflows. And OpenClaw is one example. So today we are building these agentic workflows using orchestrators, which are part of the library itself in LangGraph, Crew AI, or Microsoft AutoGen. So important thing is mastering agentic RAG workflows is going to give you the highest value skill in the market where there are NLP or LLM related jobs out there. So if you can build an agent, your value as an engineer become quite limitless if you know how and what need to be done to build a very robust production ready agent. And this is the exact shift from basic chains to powerful agentic systems. And this is something which I'll be doing probably in the month of March, a workshop on OpenClaw. And this workshop is going to give you a very, very powerful way of how to use cutting edge agentic AI system on your day-to-day activities, including doing a lot of items from sending emails, autonomously writing, let's say, a long amount of documents, even helping with the research work. So OpenClaw is quite powerful in terms of doing it. Now, let's shift gears and try to touch a little bit of different concept. If you're a student sitting like thinking about how do I actually prove to the top companies that I know AI, okay, like how do I tell the other company that I know AI, I know these things? So the answer is simple. You need to stop going through theory courses and you need to start building a portfolio of complex real world data pipelines. A very interesting project which you can build on Saturday and Sunday is an end-to-end YouTube video summarizer. So let's look at, let's say, a use case in India. Think about UPSC aspirants watching 3-hour long lectures from, let's say, Drishti IAS, or engineering students grinding through NPTEL tutorials. Like even I've gone through them, a lot of them actually, when I was in college. So watching the whole thing, it takes a huge amount of time. The only way for me was to do a +2 kind of read, or sometimes even multiplied the speed by 3. So think about it. If I can just paste a YouTube link and get a perfectly structured timestamp summary in seconds, so that I can directly jump to the topic which I'm looking for. So what do? You build a concept with the agentic system where step number 1 is transcription. You extract the audio and pass it through a speech to text model, and don't just use the standard OpenAI API. Instead, to stand out, you should use some open source optimized libraries which you can run locally. Maybe look into something which I also tested and experimented, which is Whisper, or there's WhisperX. So WhisperX is something which gives you highly accurate word level timestamps and speaker, let's say, different digitized text. That means you can know exactly who is speaking and when. And even if they're speaking in English, it helps you. So just check for Whisper. Then in step 2, what you do is you have a context problem which you need to solve, because you have 50 pages of transcript which has come out in a 1-hour video. So if you just copy paste that to the large language model and put a prompt, it will fail, because as I've suggested earlier, and this is something which was also mentioned in research paper, and if you want you can read that research paper. It's called as Lost in the Middle, how large language model use long context. Very interesting paper. So the researchers proved that if you feed an AI a massive wall of text, it perfectly remembers the beginning and the end, but completely forgets the crucial information hidden in the middle. So just look into this paper. And then you jump towards the step 3. So once you have done the contextual resolution, where the problem was the context memory size and all, or you split it into everything around it, what you do is you use in LangChain, there is basically a concept which is called as map reduce. So in the LangChain architecture, this map reduce, what it does, instead of sending the whole text, you chunk the transcript into 10 similar parts. So the map phase, which is basically the phase number 1, the AI reads each part individually in parallel and writes 10 mini summaries of it. And then you have a reduce phase where the AI takes these 10 mini summaries, combine them and writes one project, highly accurate, which is like a master summary. So this is like an enterprise grade engineering which you can actually do on your own. And maybe if you need any support, any help, just send a message on WhatsApp. Like we'll help you with and even what I'll do is on the weekend, maybe I'll put a GitHub link, or maybe next week, of this entire process which I've talked about, and you can use it. When we are interviewing AI engineers at Create Bytes, if a candidate explains that they are using MapReduce to solve, let's say, even if they just tag the paper name lost in the middle problem, that candidate instantly stands out among the crowd or the people whom we are interviewing on a regular basis. So it's important to know and understand. Another thing which is interesting and which is quite powerful is to talk about something which is very interesting and is going to be the frontier in the AI industry, which is the voice. So the future of human computer interaction is not going to be typing or textual, it is going to be voice. So if we truly want to scale AI in India for a population of over 1.4 billion people, we have to realize that typing complex English prompts is a massive barrier. Let's say you are building something which need to scale for Indian population situation. Imagine farmer in rural areas where they have a small shop, or let's say they're talking to someone to buy their, let's say, weed or other materials which they need for their regular farming activities. They can't navigate complex web portals. But what if they could just speak into their phone, say in Hindi or Marathi or whatever language they're using, what is the exact process to apply for PM Kisan Yojana subsidy this year? And an AI instantly replies with the exact policy details. This is called a voice assistant over a knowledge base, and it is ultimate test of an AI engineer. That how you can do it, because there are complexities. Still in the SOTA, we'll see that building some things in near real time have complexities. And I'll touch some of these, which is one of the thing is STT, which is called as speech to text. So the user speaks to handle the Indian region languages. If you look at the indigenous models, you will find one which is called as Bhashini. It is built by Indian government, or you can touch some foundational Indian startups, and one of them presented in the Indian AI Summit, which is basically Sarvam. And then there are also like Meta's M4T, which is a research paper which also talked about like a kind of mastering massive multilingual speech translations and all. Then you have a RAG system, which is, let's say, transcribed Hindi text. It hits your vector database, instantly fetching the correct government policies from thousands of internal documents. Then you have LLM generation. The model generates the factual answer based purely on the retrieval documents. And then you have text to speech, which is TTS. So finally, we convert that text back into the natural human sounding Indian voice. And there are, let's say, good state of the art, like 11 Labs is quite good. Sarvam TTS is also like they've displayed good outcome there too. But this is where the real engineering challenge lies, which is latency. And this is something which we are also facing, and we are trying to do some things at our end. But yes, this is a genuine problem. If a user asks a question and the AI takes 8 seconds to process all 4 steps, the user will think the app is broken. In production, we obsess over a thing which is called as time to first token. To fix this, what we can do, or like a lot of engineers, what they're doing is they're creating streaming architectures where the AI starts speaking the very first word of the answer while it is still generating the rest of the sentence in the background. On top of it, you have to handle interrupt detection using voice activity detection, which is called as VAD, which is basically if the AI is speaking and the farmer cuts the AI off to say, no, I meant the subsidy for wheat, the AI must instantly stop speaking, clear its memory buffer, and listen. To build this, there are a lot of open source orchestration frameworks like PipeCat, which are available to manage these real-time audio streams. And for the researchers, and let's say if you guys are trying to experiment, you'll see, and this is something which we are also viewing, a massive shift right now towards end-to-end native audio models. So like models like OpenAI GPT-4o and then 5.1, 5.3, it all started from there, 4o, and then it started improving and improving. So real-time APIs, or let's say open weight Moshi model, is again very powerful. So we'll share these links too. Like they have achieved latency under 300 milliseconds, which is humongous. And with this, I'm going to touch the very last thing, and it is important, and I'll just put it in a very, very strong sense that the harsh reality of building AI in the real world, and this is something which I have also faced, when you build your first RAG pipeline and you hit a run and it says that, like, I'll tell you this thing, this is something which I have been doing, and not just with RAG, but I've seen it with a lot of AI tools which we build, that it is gonna fail first and there'll be a lot of issues which will come. So let's say you're building a customer service bot for an Indian bank like HDFC or SBI. A user asks, what is the penalty for breaking a fixed deposit early? And the bot confidently hallucinate a completely wrong percentage and says 24%, 30%, whatever. And this is like something which is not acceptable in production. But what is the biggest mistake here? If we see that there is some issue, we instantly, most of the time, just blame the LLM. We say that like this LLM is hallucinating again. It is not doing it correctly. Let me write a longer prompt, switch the prompt, do something around it, maybe switch the large language model and change it. Do not immediately come to a conclusion. 90% of the time, the LLM is completely innocent, and we need to know that. The issue is your retrieval layer. The LLM is just a highly intelligent reasoning engine. If you give a brilliant student the wrong textbook, they will still fail in the exam. So if your database fetches a PDF from 2018 instead of 2024, the AI is going to give you answer from 2018. If your chunking strategy is incorrect, splitter is something which you're not using it in the right direction, your embedding strategy has some issues, your context compression is not good, there are a lot of things which can go wrong. Do not immediately come to the conclusion that LLM is wrong, and it is important. So like at a very high level, check for, did it pull the right data? Are your chunks too big? Upgrade your architecture. If standard search fails, maybe we can think about having a better re-ranker and all, but think from a bigger context perspective to know what's happening. And then I'm gonna touch the final takeaway for us. And if you take only one single thing away from this entire webinar, and I wanna like emphasize it to the largest extent possible. So this is the mind shift. RAG is not just taking an OpenAI API key and plugging it into a vector database. You need to know that, and you need to understand. And that was something which was like maybe 2023. It was at that time where it was happening, but now it has drastically changed. Today, production grade AI is like very, very interesting engineering, a good architecture, a lot of complex scenarios are there, very deeply mathematical and very layered system. You have data ingestion, smart chunking, high quality embeddings, scalable indexing, precise retrieval, dynamic prompting, and then finally generation, and then a continuous evaluation of that on top of it. And the industry at this point of time is moving humongously fast. So the thing which we saw earlier, the basic 8-step diagram, that has evolved, and now we have entered in the era of agentic RAG. So if you want to stay ahead of the curve and impress, let's say, the people whom you are working with, your colleagues, or where you are joining in the new companies where you'll be interviewing, I encourage you to read 2 state-of-the-art research papers and maybe do it on Sunday. One is Search About Self-RAG, and the other one is CRAG, C-R-A-G, Corrective Retrieval Augmented Generation. In standard RAG, if the vector database returns bad or irrelevant information, the AI is forced to use it and hallucinates. But in the corrective RAG, we build a smart AI agent in the middle. The agent evaluates the retrieved document and says, wait, the internal document is outdated. I am going to reject this, rewrite the user's query myself, and automatically trigger a web search tool to find the live answer from Google Lens. And this is like a true autonomy. So this is a system correcting its own mistake in real time. And these are the agentic systems that are powering the next generation softwares at CreateBytes and Alteryx too. And a couple of them are already live, which you can look at, and very, very powerful. But no matter how advanced the AI agents are gonna become, the golden rule of enterprise AI remains exactly the same. Control the retrieval and you will completely control the hallucination. And it's important. Control the retrieval and you'll be able to get a complete, or maybe a kind of a power towards how you can limit hallucination. When you master this, you don't just build, let's say, basic demonstrations. If you're able to do it correctly, you will get inside a team of elite enterprise building engineers. And it's very important that you specifically get inside these research papers, understand the basics and all. But yeah, this is it. So I think we can wrap up, and I want you to understand that these kind of RAG systems and then the open claw workshop which we'll be doing are gonna help you become better engineers. And I'll try to limit myself with as less theory as possible, but as many practical libraries which we are using right now, and then the things which we have seen with computer vision and NLP on a regular basis. But before that, I want to invite you to take the next big step in your careers via just practically getting inside the practical implementations of these things. Take out your phone, your mobile phone, whatever you have, just scan this and then follow CBX on Instagram. You'll be able to see a lot of videos which are related to new libraries, new tools which are coming out. It will be interesting to just basically get a heads up of what you can do. So the whole idea of the channel is to just put as new information or relevant information as possible at mind. Once you follow CBX Insta, someone from the team will send a text directly to you with an exclusive link to join our WhatsApp community. And this is something we're definitely going to interest you. In the WhatsApp group, we have started doing it, and the team is putting a lot more effort in terms of making it much more bigger, where we can share actual GitHub projects, because we have an open source GitHub repository. I want you guys to contribute. Again, I am someone who is part of open source community, and in India we don't emphasize it much, but you do not understand the power of open source, and you guys should, as much as you can, maybe just put a fork or add a commit, create an issue, participate in open source GitHub projects. Like, you can get cutting edge research papers, powerful agentic systems which are templates which we use. I'll be aligning special hands-on workshop around how to use OpenClaw next month, and we'll be giving information there itself that how and when it is going to happen. So definitely an interesting thing which you should be using. But yeah, coming back, the one thing which I want you guys to always know, it's not about learning new tools or learning, let's say, practical knowledge or theory. One thing which is happening, and this is happening with me too, the only thing which we need to learn in this era is how to learn faster, how to adapt faster. And that's where I want to conclude. And this is Aditya, and have a very great day. If you guys have any questions, definitely do ask there. But yeah, this is good enough. Thanks a lot. Have a very good day. Bye-bye.